and the implications of comets colliding with Earth. The Comet Nucleus Tour, or CONTOUR mission, was designed to study two very different types of comets at extremely close range, to dramatically improve our knowledge of key comet nuclei characteristics and unravel their diverse evolutionary processes. Unfortunately, contact with the spacecraft was lost 6 weeks after launch, following a propulsive maneuver to send the spacecraft into its comet-chasing solar orbit. Limited ground observations identified what appeared to be 3 separate objects near CONTOUR's expected position. 4 possible causes for the failure were identified, but the probable proximate cause was structural failure of the spacecraft due to plume heating during the embedded solid rocket motor burn. Discovery's moon and planetary missions are helping to understand the connection between the inner planets by conducting close-up studies of the structure and composition of these rocky bodies. With NASA's first return to the Martian surface in more than 20 years, Mars Pathfinder performed science experiments for nearly 3 months after achieving its primary goal of demonstrating a low-cost method of delivering science instruments and a small rover to the surface of the red planet. After a 6-month journey, Pathfinder descended through the thin Martian atmosphere, using an innovative system of parachutes and retro rockets to slow the lander. Enclosed within a giant system of airbags to cushion the impact, it free fell and bounced as high as a 10-story building due to the low Martian gravity. Once deflated, the airbags opened a path for the Sojourner rover to begin its historic exploration. Rock and soil samples at the landing site were analyzed. Atmospheric and weather conditions were monitored, and Pathfinder conducted the first astronomy studies from the surface of another planet. The science teams analyzed extensive data returned on the planet's geology, magnetic properties, mineralogy, and geochemistry. Mars Pathfinder returned more than 16,000 images from the lander and 550 images from the rover. Findings suggest that in its past, Mars was warm and wet, with water existing in a liquid state and a thicker atmosphere. Mars Pathfinder was a great success, providing scientists with large amounts of data, pioneering new technologies, demonstrating the feasibility of launching lower-cost planetary missions, and playing a crucial role in advancing NASA's long-term plan for Mars exploration. It also was the first mission to offer real-time coverage on the Internet, drawing an unprecedented 47 million hits in one day. The public was riveted by the remarkable photos of Mars and the pint-sized visitor from Earth. More than 3 decades have passed since Mariner 10 flew by the planet Mercury on a mission that mapped only 45% of the planet's surface. Messenger will continue the legacy of Mariner 10 with a comprehensive scientific investigation to orbit the solar system's innermost planet for the first time. During its 7-year journey, Messenger performs a gravity-assisted flyby of Earth, 2 flybys of Venus, and 3 of Mercury, the most complex set of gravity assists for a space mission. The Mercury orbit phase begins in March 2011. Messenger will map nearly the entire planet in color, capturing never-before-seen views and measuring the composition of the surface, atmosphere, and magnetosphere. For 1 Earth year, the spacecraft will be subjected to extreme temperatures, from scorching sunlight to the frigid night side and the permanently shadowed poles. Messenger's 7 miniaturized instruments will return data to answer key scientific questions about Mercury's thin atmosphere. its inconsistently high bulk density, and the forces that have shaped its geology, all fundamental to understanding the terrestrial planets and their evolution. After a 5-day transit to the Moon, Lunar Prospector successfully completed a 19-month global study of the Moon's surface, providing insights into lunar origin and evolution, while attempting to determine whether water ice is present in the Moon's polar regions. A wealth of data collected by the 5 spacecraft instruments from a nearly circular lunar polar orbit 62 miles above the surface enabled scientists to create the most detailed maps to date of the Moon's gravity, magnetic properties, and chemical composition. Upon completion of its mission in July 1999, scientists targeted the spacecraft for an impact inside a shadowed crater near the lunar South Pole. If water ice exists on the Moon's surface, scientists thought the impact could free up water vapor that might be detectable from Earth-based observatories and the Hubble Space Telescope. Although the controlled impact produced no observable evidence of water, analysis of neutron spectrometer data confirms previous indications that ice does exist at the Moon's north and south poles. Lunar Prospector provided scientists with tremendous new insight into Earth's closest celestial neighbor, the Moon, and enhanced our understanding of solar system origins.